Hello.
Yes, sir.
Yes. What they have taught in this week? Did they taught about numerical differentiation? Okay. Forward and backward difference in cubic polynomial. Yes. And was it forward and backward difference or was it forward and backward divided difference? Divya, we earlier we have seen various methods for interpolation, right? So, do you remember what are the interpolation method which are used for unequal intervals? People write in chat box. Do you remember what are the methods used for unequal intervals? Raghuram Pudi Venkata. I cannot able to see the entire name. Are you there? Hello. Unless you tell me, how can I start? What are the things is being taught? I'm asking some things from the previous class. No one is responding. Why it is so? Gomati, at least tell me in the chat box whatever has been taught or what I asked. I asked what are the interpolation technique being used for unequal intervals. No one knows this. We have specifically mentioned at the start of the PDF. Are you able to listen me? Lagrangian and Newton's divided difference. Yes, correct. Lagrangian and Newton. Okay. These things are being taught right in previous classes, in theory classes. See, if I take time for starting, it will also, the session will be extended. Respond quickly so that I can also wrap up quickly. At least respond in chat box. Had we studied Bessel function, Bessel formula for the central difference last time? Hello, Divya, Kirti, Bharti, Bharti Virasamy, Sai Krishna. No one is responding. How can I start? Hello, are you able to follow me? What I am saying, are you able to hear? This is being recorded, okay? It can hamper your certification. Sweta, Priyadarshani. Yes, sir. What? Yes, sir. I am asking what are the topics being taught in this week. Just give me the list in the chat box.
Uh, Hello, sir.
Yes.
I just went for the little break. Actually, I'm working.
Okay.
Uh,
So,
Last week and before last week also I missed the session, sir. So starting two sessions I listened very clearly. So I got little idea about the numerical methods and all. Then later on, due to my uh, like job responsibilities and work nature and all, regarding all that, I didn't attending, sir. So
okay, okay.
I
Anyone
don't know
else?
what.
No, no issues. Anyone else? Gomati, do you know what topics been taught? I will take according to the week. The problems I am supposed to do is whatever you have been taught in the week. So based on that only. So please respond. Yes, this Kirti, unmute your mic, Kirti. Divya. Yes, yes, yes.
Sir, if you don't mind, can I talk to you personally, sir?
Why?
Regarding my last 4 weeks session and all.
Okay, we will see that later. Okay, you
Okay,
just
sir.
unmute. Yes, Gomati. Gomati. Gomati, are you there? Divya, are you there? No one is there. Sweta is there? Priya Darshani. Priya Darshani, are you there? Please respond. Unmute your mic and please respond. See, time is running. Okay. If you make late, I have to make it even more late. At least respond in the chat box. Had they taught you about numerical differentiation in this week? Had they taught about the Bessel function, Stirling function, which we did in the last session? What topics they have taught? Just list it down in the chat box. Malarviji, hello, Malarviji, hello, Nitya, Hello, Karthika. Are you there, Karthika? J. Muthurulappan. Are you there? This way, cubic polynomial. Okay. Only cubic polynomial. Forward and backward difference cubic polynomial. Okay. So, in this week, in the last week, we did interpolation. Okay. So, in interpolation, we see the methods for equal intervals and unequal intervals. So, for equal interval, we have used Newton's forward difference, Newton's backward difference, right? Then your Stirling central difference. Central difference has two methods, right? Central difference has two methods, Stirling and Bessel. Okay, and in a unequal, we have done Newton's divided difference method and Lagrangian polynomial or Lagrangian interpolation method. Correct? So, among this, we have done these things. Okay, we are left with the Bessel's central difference. Okay, from your theory, you can write the formula for the Bessel central difference. Okay, so we will solve the problem. Okay, whatever we use to do in equal interval, the common step in these methods and this method is to find difference table, right? Are you following? Right? Right? So this is this so we will take first Bessel function, this Bessel interpolation. Okay, after that we will move to numerical differentiation. Numerical differentiation. This I will explain. First we will take one example, okay, which was remained last time due to lack of time. So okay, write down the your example. Example is we have given values of x and its corresponding function value, that is y. Okay, x values are 20, 24, 28, 32. Okay, and the corresponding y values are 854, 3162, 3544, 3992. Okay, now you have to find value of y at x is equal to 25. Okay, so tell me what will be the order of the polynomial which can be fitted in these data points? What is the order of the polynomial which can be fitted in these data points? There are four data points, four set of data points, right? So what is the order What is the order of the polynomial which can be fitted in these points? Yes, answer fast. This is very simple question. Yes, Gomati, what is the order of the polynomial which can be fitted in these four data points? No, there are four data points. So what will be the order of the polynomial? Gomati, the answer is wrong. Just recollect what I have said in the last session. Third order, right? Muthuralapan. I am not able to pronounce your name. Sorry for that. But your answer is correct. Okay. We have four data points. So order of polynomial which can be fitted is one less than that. Right. So is it clear? Is this clear? Yes, yes. Correct, correct, correct. Okay. So we will write our basic difference table, right? We know how to write difference table. Everyone knows this, right? X, sorry, X and Y. We have X values. Okay, okay. Before that, we are using Bessel interpolation CD, right? In CD, we have seen two methods, right? In central difference interpolation, we have two types of interpolation, right? Bessel and Stirling. Okay. How we decide which to use? Yes, in the given problem h is 4, right? So how we decide that which method to be used? How we decide this factor? Yes. No, not equal. We can use these CD methods. These methods CD, Newton's forward difference, Newton's backward difference, central difference. CD is central difference. Okay. CD can be done in two ways, Stirling and Bessel. Okay, so all these methods are can be applied for equal interval problems only. Okay, so there is not that is not the reason. Okay, how we decide? We decide on based on the value of p, right? What is value of p? P is x minus x naught upon h, right? Right? Right or not? Are you able to recollect this? We have seen this in last week when we have to do Stirling. Okay, there is some range of value in which we can do. So do you remember? Yes, Priyadarshini. Yes. Yes, 25 is the middle value of data, right? We, we are finding out the values of y for given value of x, which is at the center of the table. That's why we are using central difference interpolation, right? But central difference interpolation has two ways, Stirling and Bessel. So which to use? How we decide that? We decide that based on p values, right? Whatever the p is calculated, based on that we decide. So what is the range of p values we use for Stirling and what are the range of p values which are used for Bessel? I have taught you in the last this last problem solving session. So are you guys remembering that? I'm writing this again. Okay, for Sterling, value of P ranges from minus 0.25 to 0.25. We will use it for Sterling, and the value of P ranges between 0.25 to 0.75. Then we use Bessel. Okay, now in this our what is value of our x0? What is the value of x0? Yes, we can take any x0 value, okay, but it should be at the center. Earlier we have taken the example with 5 points, okay, so 1 2 3 4 5. So third was the this central value. So in this we have only 5, so we can take either 2 or 3. So here we are taking 2. So x0 value is 24, second value. X value is 25. So what is the value of P? Value of P is value of P is
0.25.
0.25. So in 0.25 you can use both these methods, okay, because for 0.25 we can use both Stirling and Bessel method, but as we have done the Stirling problem, we will do it by Bessel method, okay. But this is very important point. You should know when to use which type of central difference interpolation. Okay. So we will start writing the our table. So what is our table? Okay, x is 20, 24, 28, and then 32. Right. Then we have value 2854. We have value 3162. We have value 3544, and then 3992. What are the values of P for these each x values? So for this it is 0, right? 20, see, I'm showing this here. Okay, 20 minus 24 by 4. 24 minus 24 by 4. 28 minus 24 by 4. 32 minus 24 by 4. Is it clear? Right? Are you getting? Are you getting? People? So tell me the your first difference. What will be the first difference? What is the value of first difference? For your convenience. Okay, for the convenience, I just right. What will be the first difference? Yes, first difference 3162 minus 280, 2854, right? 308. then 382, right? Then yes, value between 28 and 32. What is the value? First read, first this difference 448. Correct. Okay. Second difference. What will be the value? Yes, 7466. Correct. Correct. And this third.
-8, sir.
Correct. -8. Okay. So okay. Just for our convenience, uh, we'll write y1, y0, y1, y2. Sorry, y minus 1. Okay, so this is delta y minus 1. This is delta y0. This is delta y1. This is clear, right? What is it clear why it is delta y minus 1?
Yes, sir.
Okay, what will be this?
Y-1.
Okay, this
Delta square Y naught.
delta square y naught. Correct, correct, correct. Now you guys are getting these things. Okay, we know from theory the formula for the Bessel. We can find out y for given x value as by Bessel interpolation formula. You can write y0 plus p del y0 plus p into p minus 1 by 2 factorial into delta square y minus 1 plus delta square y0 by 2, okay, plus p minus 1 by 2 p into p minus 1 upon 2 factorial del cube y minus 1 and so on. Okay. Okay, one thing I want to tell you, there is some lightning going on outside, so if there is any interruption due to internet, okay, so we'll continue after that. Okay, okay, okay. What is the value of y0?
P162.
P162, correct. Value of p,
0.25.
right, 0.25. Value of delta y0, where we can say this
382.
382, correct. Okay, plus 0.25 0.25 minus 1 by 2. Okay, what is the value of delta square y minus 1? Delta square y minus
74.
74 plus 66 by 2, correct?
Yes, sir.
Okay, then 0.25 minus 1 by 2, 0.25, 0.25 minus 1, 1 to factorial. Okay, delta cube y minus 1. What is the value? Minus 8, correct? Yes, give me the answer. Calculate, take your time, give me the correct answer. 3162 plus 0.25 into 382 plus 0.25 into 0.75 into minus 1 by 2, okay, into 74 plus 66. You guys have calculator, right, in your hand? Plus 0.25 0.5 into 0.25 by 2 into minus 8. Okay, what value did you got? Okay. Uh, is this point clear that CD, how you decide the CD? Okay, you first solve. Tell me the answer. Yes, Muthurullapan. Muthurullapan. I'm very sorry. Uh, did you find out the answer? Yeah. Ravi Shankar, did you got the answer?
Sir, I'm doing now, sir.
Okay. People who have got the answer, they can write in the chat box. Uh, your answer seems to be correct, but there is slight mistake, I guess, Kirti. Okay. I got it. There is some typo error. Okay. The answer is correct, but yes, Kirti got correct answer. Good. Okay. Yes. My voice is breaking. Is it not audible? Is now or is it now audible?
It is audible, sir, but in between it breaks. Sir.
Yeah. I am not actually in between. I am not talking anything. Okay. You don't worry. You can also ask any doubt you have in the this chat box. Okay. If you are not able to hear, has everyone got this value? 3250. Yes. Divya, Gomati.
Yes, sir, I got the answer, sir.
Okay, good. Gomati, Priyadarshani, Sarumathi. Okay. Okay, good. Okay. So everyone is now got. Okay, is it clear that we decide based on value of p which method to be solved? Okay.
Yes, sir.
Okay. The central difference is always used for the condition where we have to find the value of function at the middle of the table. Okay, which I have taught you in earlier classes. Okay. When we want it at the top of the table, what we use? When we want the value, a particular value near to the top of the value of the table or near to the first values of the table. Which kind of interpolation we use? Yes, forward interpolation. And for the bottom of the table, so we use forward interpolation if the value of x to be find near to the first values. Okay, like if it was value to be find at 21, we would have used forward. If value needs to be calculated, say at x is equal to, sorry, say at x is equal to 30, then we would have been used backward difference. Okay, and now as we are calculating value at 25, which is at the middle, so we have used central difference. Okay, is this clear?
Yes, sir.
Okay, okay, okay. So let's start with the numerical differentiation. These are there is nothing difference in interpolation and numerical differentiation. Okay, we are going to use the same techniques. Okay, only thing is we will find out differentiation. That means we will find out derivatives first, second, whatever. But we will be concerned with these two types of derivatives. Okay, you can calculate any order of derivative with numerical differentiation. We will for now we will calculate this one. Okay. The numerical differentiation can be done in the various ways. It can be done based on interpolation. It can be done based on finite difference. Okay. Interpolation one is what we are being doing from last week. Okay. So ways will be same. Okay. There is slight difference in the formula due to derivating the functional term. Okay. So numerical differentiation based on interpolation. Okay, here also the same thing. For equal we will use Newton's forward, Newton's backward, and uh, Bessel and central Stirling interpolation for equal interval problems, and for unequal interval we will use Lagrangian and Newton's divided. Okay, so you must have uh, come across the formula for finding out derivative with the help of Newton's forward difference, right? Did you uh, did you come across the formula? Anyone knows the formula? Anyone knows the formula for first derivative using Newton's forward interpolation? First derivative using Newton's forward interpolation. Yes, anyone knows this? Okay, no issues. First derivative using Newton's forward interpolation is given as dy by dx is equal to 1 by h del y0 minus del square y0 by 2 plus del cube y0 by 3. Okay, we will write first general formula. Okay, dy by dx is given as 1 by h del y0 plus 2p minus 1 by 2 factorial del square y0 plus 3p square minus 6p plus 2 by 3 factorial del cube y0 plus 4p cube minus 18p square plus 22p minus 6 upon 4 factorial del raised to 4 y0 and so on. Yes, this formula has been taught, right? Similarly, second derivative, differentiating above equation, we will get the second derivative, right? If you differentiate dy by dx again by dx, you get d2y by dx square, right? So the formula for it, this is the formula I am talking about, Newton's forward, okay, based on Newton's forward interpolation, okay. So 1 by h square into del square y0 plus 6p minus 6 by 6 del cube y0 plus 12p square minus 36p plus 22 upon 24 del raised to 4 y0 and so on. Okay, okay, is this clear? You have gone through these formulas, right? In similar fashion, we have formula for backward interpolation, right? So before going to backward interpolation, let's solve. Okay, we will first go. We go through the formulas. Okay, so for backward interpolation, yes. Anyone knows? Hello. Has anyone have idea? Very simple. It is just like forward. Only difference will be, what will be the difference? This is very simple question. What will be the difference? In Newton's forward interpolation, okay, in Newton's forward interpolation, when we use Newton's forward interpolation, when values are at the beginning, okay, we have values from x0, x1, x2, dot 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 xn, okay. When values are near to this, we will use fd. When values are near to this, we will use bd, that is backward difference, forward difference, right? When value is at the center, we will use cd. Okay, so in fd we have x0, means 0 0 0 0 terms will be there, right? So what will be in case of backward? What will be in the case of backward? Yes, anyone? I'm asking very simple questions. Newton's backward? Yes? There will be, there is nothing like, here only difference will be y0 will become yn, right? And p will, yes, plus, right, correct. P minus terms will become p plus terms, right? Like we have seen in this Newton's same formulas, right? So 1 by h delta yn, or sorry, nebula yn, you can write nebula yn plus 2p plus 1 by 2 nebula square yn, right, plus 3p square, right? Rest is completely same. No changes. Are you following?
Yes, sir.
Are you understanding what I'm trying to explain? Values
Yes, sir.
values which we are going to calculate by backward difference are near to the last values. That's why here formula will be based on yn. Correct. Similarly, second derivative will give us, how we will give second derivative. Yes, second derivative, anyone? It is same. See this
1 by
formula,
h square
right?
into
Yes, 1 by h square, right, into,
del square yn
yes, nebula square yn, correct.
plus 6p plus 6
Very good. 6p plus 6 upon 6.
divided by 6 nebula cube yn
Correct, correct, correct. Plus,
plus 12p square
okay, there is slight difference, okay, in this. But means you got the notion of the formula, right? Okay. But I think means the reason behind asking this question is you should know why, what are the difference between forward and backward, why they are used. Okay. So okay. So it will be, now we will see some application of this, okay, through the problem. Okay, so we will take some, okay, let's take this problem. Okay, example. Okay. Hmm. See, we have x values as 1, 1.1, 1.2, 0.3, 1.4, 1.5, 1.6. Okay, what is the h value? Yes, what is the h value?
0.1
0.1, sir.
Yes, correct. 0.1. Okay. So can we apply these formulas? We can apply these formulas, right? We have equal intervals, right? Aim is to find dy by dx and d2y by dx square at x is equal to 1.1 and x is equal to 1.5. Is it clear? Problem is clear. We are supposed to find first and second derivative. Okay, okay, at 1.1 and at 1.5. So tell me which formulas will be used for 1.5. What technique we will use for 1.5? X is equal to 1.5.
Forward.
X is equal to 1.5.
Backward
Backward.
difference, sir.
Yes, backward, because it is at the end of the table, right? And for 1.1, forward, right? So we have the formulas, correct? So uh, let us first calculate the table. Okay. You calculate the table x, y, 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, okay, 7.989, right, 8.403, 8.781, right, 9.129, 9.451, 9.75, and 10.03. Okay, let's start finding the difference table. Okay, will okay, whenever I write this difference table, I'm going to write in this way, right? Is there any difference between this? This will be for forward, right? For backward, will we do we need to calculate different table? Are you understanding my question? We are calculating difference table, right? We calculate first difference, second difference, third difference, fourth difference, and so on, right? Okay, this we calculate for forward difference, right? Is there need of calculating different table, different means, is there need of calculating the difference table differently for the backward difference? Are you understanding my question?
So no, sir, there is no need to another table.
Why? Your answer is correct, because the difference which we take is always next minus previous, whether you take forward, whether you take backward, right? So this delta, we just use different symbol for different kind of differentiation interpolation, right? Difference interpolation, right? So but the difference will be always next minus previous, so there is no need, right? Okay, so calculate the values. What is the value? Yes. Hmm. Yes, values. Yes, 0.414. Correct. I'm writing. I calculate the table and match with me. If it is, if you are calculating correct. 378. Yes. After 0.378, we have 0.348. Just simple difference, right? 0.322, 0.299. Yes. Next onwards. Yes. Tell me. What are the values? Del square value? Yes, 0.299 correct, 0.281 is correct, right? Del square values? Sorry. Yes, minus 0.036, minus 0.03, correct, correct, you are going correct. Minus 0.023, minus 0.01, correct. Okay, cube. Yes, cube. Okay, just write down the values. Fourth, this is minus, okay. The rest to 5, rest to 6 is also there. I'm just not writing the arrows, okay. Okay, so which branch we will take for forward difference? Yes, yes, correct. Uh, okay, now first we will need to find P. P is x minus x0 by h. Okay, so our x is at what value we have to find? 1.1 minus x0 is 1 upon h is 1. So value is 0.1. Okay, okay, with this value, okay, okay, what x0 we have taken 1. Okay, so which branch we will take for the calculation? We are calculating forward difference, right? So for calculating, we will use this formula. Okay, we have to find first derivative, right? So first derivative is given as 1 by h, 1 by h del y0 plus 2p minus 1 by 2 del square y0 plus 3p square minus 6 plus 2 by 6 del cube y0 plus 4p cube, yes, 4p cube minus 18p square plus 22p minus 6 upon 4, that 4 factorial, that is 24 e raised to 4 y0. This much accuracy is in. Okay, so find out the value of dy by dx. 1 by h, what is 1 by h? 1 by h, right? Del y0, what we will take? we'll take this branch, right? Because we are doing forward difference, right? So 2 into what, 2 into 2 into point 1 minus 1 by 2. What is del square y 0? Sorry, first del y 0. What is del y 0? 0.414. Del y 0 is 0.414, right? Del square y 0 is del cube y is 0.006 plus 4.1 cube minus 18.1 square plus 22.1 minus 6 by 24 into del raised to 4 is minus 0.002. Calculate. Did you understand this? Are you guys following? Are you guys following?
Yes, sir.
Yes.
Yes. Okay, calculate. What is the value? What is 0.002? Has anyone calculated? Has anyone calculated the value? Tell me the individual values. 0.414. Next value. What did you got? What is the second value you got? What is the second value?
0144, sir.
Right. Third value?
0.00143.
0.00143. And last value?
0.000331.
Okay.
4.3016.
Okay, let me check this. Okay, you got the answer as 4.306. It is correct. Okay, okay, okay. But there is one difference. Okay, we have calculated this by normal or forward interpolation. We have calculated it at 1, right? We want at 1.1. Okay, so this is what dy by dx at 1.
First derivative.
The first derivative at x is equal to 1 because our x0 is at 1. We want x0 at 1.1. So you guys now calculate at 1.1, which we need. This is just for the practice I did. Now you calculate for x is equal to 1.1. So what will be the p? Sorry, at x is equal to 1.1. What will be the p? What will be the p? 0, right? P will be P will be hello. We have calculated at 1. Okay, taking x0 1.1. But we want to calculate at 1.1, right? So we take x at 1.1 minus 1.1 upon 1. So our p will become 0. Once p becomes 0, the expression even simplifies, right? So tell me the answer for dy by dx at x is equal to 1.1. Which branch you will take for 1.1? Just write the numbers in that branch. Hello, are you following? Hello, are you getting what I am trying to say?
Yes,
I,
sir.
I am trying to say is we should take p value at x is equal to x naught itself. So if we take both x and x naught 1.1, so we will not have to calculate these values that rigorously. Okay, are you getting?
Yes, sir.
Okay, so calculate. So what will be the p? P will be 0.
0, sir.
Okay, so for that p, what branch you will take? You will take this branch, right? Right? Are you following? Whenever we calculate differentiation, whenever we calculate differentiation, okay, okay, whenever we calculate differentiation, this is just for the practice, okay, whenever we calculate differentiation, we try to make p value 0, that is value at which we are finding an value subtracting from it should be same. Means in FD, x and x naught will be same, and in BD, x and what will be same?
N minus 1, sir.
Xn,
X minus 1.
xn, na? Xn. This is the main key in this thing. So your calculation will be reduced. Okay. Did you means is it clear why it is xn and not xn minus 1? When we calculate for forward difference, we calculate p as this, and backward difference we calculate p as this, right? So xn should be same, right? Is it clear? So I want from you the answer for dy by dx at x is equal to 1.1. So 1 by 0.1. So delta y0 will be what? What will be the delta y0? 0.378, not 3.78, 0.378. Okay. Then your del square p value is 0. So 0 minus 1 by 2. Del square y 0 is minus 0.03 plus 2 by 6, that is 1 by 3. Del cube y is 0.004. Okay, plus 1 by 24 into minus 6. Del raised to 4 is minus 0.001. So what is the dy by dx value? Calculate. By 3 into 0.004, 3.78. uh, Again check your answer, Kirti. Check your answer. What answer did you got? Yes, guys. Yes, correct. Kirti, correct. 3.945. Similarly, calculate first derivative at x is equal to 1.5. Okay. What will be the p for this? What you will take x? You will take x,
1.5, sir.
xn,
1.6.
same, right? So p will be 0. So your uh, what we say, which branch you will take? Just name the numbers. Call the numbers of that branch. Yes, which branch we will take?
9.75.
What? Yeah, huh? Yes. Go ahead.
9.75, 0.299,
Correct. Then
minus 0.023,
correct.
0.003, minus 0.001,
Correct. You got that. Okay. So calculate dy by dx. X is equal to 1.5. So what is the value? How we will calculate? We have the formula, right? For backward, what is okay 1 by h. So again 1 by 1.1. What will be the nebula yn? What will be the nebula yn? Yes, nebula yn. Anyone? Nebula yn?
9.75.
What 9.7? Nebula yn. This value. Nebula yn.
0.299.
0.299, right? Okay. Then second value, what you got? Minus 0.023. 0. So again 1 by 2. Okay. Next 0.003. Yes. Anyone find out the answer? Yes. What answer did you got? Are you able to follow these things? Yes. Please recalculate. Three point 1025. No, it is not the answer. 3.1008 is also not the answer. Yes. Yes, 2.8825. Correct. Gomati got the correct answer. 0.8825. Correct. We calculated now the first derivatives. Now we will calculate the second derivative. Okay. Second derivative. Again we will use the formula. So delta u by del x square for x is equal to 1.1. Okay. What will be the P? 0. Why? Because x and x0 are same, which is 1.1. Okay. So del square y 1 upon h square. So 1 upon h square into 1 upon h square into del square y0. So what is the del square y0 here? Value of del square y0 here?
Sir, minus 0.036.
0.03. Why 0.036? It is 0.03. No, we are calculating at 1.1. So we will take this branch, no? Second branch.
Yes, sir, 0.03.
Is it clear? Hello?
Yes,
Is
sir,
it?
correct, sir.
Yes, yes. You understood, right? Where do you did the mistake?
We are taking the second branch.
Yes, yes. Okay, okay, fine. Okay, 0.03, right? Is this clear to everyone why this is minus 0.03? Gomati, Divya, Kirti.
Exactly, yes, sir.
Yes, sir.
Good, 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 good. Okay, then your 6p6 by 6. So p is 0, so minus 1, right? Minus 1 del cube y0. What is the value of del cube y0? Value of del cube y0?
0.004.
Correct. Minus 0.004, right? Minus 0.004. Then what is the value of this 22 by 24, right? So plus 22 by 24 into del raised to 4y0. So del raised to 4y0 is,
Minus 0.001.
so what is the value of second derivative? Yes, it is the value derivative. Yes, anyone? Value? Yes, correct. Minus 3.4917. Correct, correct, correct. Similarly, find for 1.5. Second derivative for 1.5. I am giving you the formula. Okay. Calculate for 1.5. Okay. One more. No, you have already the formula, right? You have the formula. Okay. Fourth term is not there. I am giving you the fourth term. Okay. 1 by h square. Is it same? Okay. Start. 0.1 square Del square yn. What is del square yn? Quickly.
Minus 0.023.
Minus 0 point minus 0 point
001, sir.
eh? What? He asked you del square yn.
Minus 0.023, sir.
Correct. Minus 0.023. See, this is your this is your x0 we are taking. We are taking this is xn. So this is your x0 branch. This is your xn branch. Okay. So del square is this table, right? This column. Hello, are you getting for the one? Am I not able to
Yeah,
see?
yes, I got, sir.
What did you understood?
Sir, that XN line branch series.
Yeah, this we want square. Then second difference for xn branch, right? That is your nebula square yn, right? Square for n, correct? So you want square for n, so you will see xn branch in square column, in this column,
Yes, sir. Minus 0.023.
right? Minus 0.023, okay? Plus del cube n. What is del cube n? Yes, Ravishankar.
0.003, sir.
Okay, 0.003. And del raised to 4 is sorry, nebula raised to 4 is same, right? Right? What is the value?
Minus 2.09167.
Right. Minus 0 point. Please correct the values. Again, check the values. The values. This minus 2.0916. Kirti got the correct answer. Yes. Yes. Okay. Correct. 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 Are you getting how to find the first and the second derivative?
Yes, sir.
Okay. Now one last problem on maxima and minima. Okay. You know the concept of maxima and minima, right? Are you guys aware of concept of maxima and minima? When we say the function has maximum value, if we have say function f of x, okay, it has say maximum value here at some x, okay. How will you calculate this x? We have maximum value here of the function. So how will you calculate this? Are you aware of this? See, we first find out the derivative, right, and equate it with the 0, okay. After that we get the roots of this is the equation, right? It is some equation, homogeneous equation. We find the roots of this equation and we substitute these roots in f of x, right? Okay, so what we do, we find, okay, I will write it more correctly. So, okay, finding maxima and minima, okay, of f of x. So, for what we do, first calculate f dash x, then we equate f dash x with the 0, right? We find out the roots of the f dash equal to, sorry, right? Are you getting this? Are you following me? We first calculate derivative of the function, then we equate it with the 0 and we find out the roots. Then we substitute these roots in f of x. Okay, so then we get two conditions. If, okay, before, sorry. Okay, we get the roots. After that, uh, we calculate f double dash x. Okay, then based on the value of f double dash x, if f double dash x is less than 0, then the x point is corresponding to maximum. If f double dash x is greater than 0, then x value corresponding to it is minimum. Is it clear? Is it clear?
Yes, sir.
What we do, while solving, we will get better idea of this. Just remember the steps. We find out first derivative of the function, we equate it with 0, find out the roots of that function, that equation, then that root is substituted in f double dash x, in second derivative of the function. If second derivative has value negative, that is less than 0, then for that x, function has maximum value. If we got positive value, then x has minimum value for that function. Okay, okay, is it clear? We will take one simple problem and we'll stop. Okay, very simple problem. Okay, write down the data. Okay, okay, we will calculate derivative by either by finding, okay, in this, what we have to find? We have to find maxima or minima, whatever it is, of f of x. Okay, so we need to find the polynomial. Okay, okay, there are two ways of doing this. Okay, we can do either by directly using the numerical differentiation formula or by finding out the polynomial. Okay, so you know what degree of polynomial this will give. What degree of polynomial this will give? There are four data points. What will be the degree of polynomial? What will be the degree of polynomial? Hello? The degree of polynomial which we get in 4 data points. What will be the degree of the polynomial? Just told you at the start of the lecture. Yes, tell me. Correct. Three. 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 Yes. Yes. So you know how to find out the polynomial by normal Newton forward interpolation, right? What we do? X, Y. We find out first difference table. Correct. What is the difference table? Yes. -2, -50, -146. Correct. Then yes, people. -48, -96. Then what will be the value?
48, sir.
48 or -48?
Minus 48.
Huh?
Minus 48, sir.
-48. Okay. Okay. Find out the polynomial. How you find out the polynomial? First you have to find out p value. Right? What is the x value in this? X value in this? Yes. What will be the x value? We have done this in last week's session. What will be the x value? We are finding out the polynomial. What will be the x value?
X, sir.
Yes. What will be the x0 value? X0 value?
0.
0. H value?
2, sir.
Correct? So, by Newton's forward, now onwards I will just write NFD. Okay? Okay. Newton forward difference. What is the y? Y is equal to y0 plus p del y0 plus p into p minus 1 by 2 factorial del square y0 plus p into p minus 1 into p minus 2 by 3 factorial del cube y0, right? So calculate. Y means f of x is equal to, what is y0? Y0 value
2.
2, correct. Then p
X by 2.
is x by 2, x by 2. Okay. Del y0, del y0 minus 2. Then x by 2 minus 1 by 2 del square y0 minus 48 plus, right? Is it clear? Find out the polynomial. X simplifies to minus 4. Okay. Yes, what is the polynomial? What is the final polynomial? Are the values calculated correct? Minus 48 minus 48 6 x by 2 x by 2. Right? Did you get this polynomial? Is this the polynomial you got? Did you got the same polynomial? Had we done the mistake? I guess we had done the mistake. Yes. We got the polynomial. Did you got this polynomial? Yes, please respond. What is x? What we got? Okay. After this, what we are going to do? Got the polynomial. What we are going to do?
We have to differentiate it.
Okay. Differentiate then. Right? And equate with the 0. So you can write this like this. So what will be the root? What are the roots? These are the roots, like, right? Right? Is this clear?
Yes, sir.
Okay. So, is this maxima or minima? Is this a maxima or minima? Have we find
Minimum, sir.
how do you know this?
Sir, no, sir. We have to do the second derivative, sir.
Right, right. Okay. What is the second derivative? Substitute the value. What we got?
0.
0. So, is it minima? Is it minima? Is it minima? It is not less greater than 0, right? So it is not minima. It is nor less than 0. So it is also not maxima. So what is this point? This is called saddle point. Point which is exactly flat to the curve. There is nothing like means saddle point with there will be abrupt change. Okay, is it clear? Is it clear? What is the value of f of x at this point? Is it clear to everyone? If this value, if this value would have been minus 2, then what will be the x? Hello, what would be the x if this f double dash value is 0, then, sorry, minus 2? What would have been? What it would have been? Yes, Ravi Shankar, Kirti, Divya. If f double dash x was minus 2, what would be the x? It would have been minima or maxima?
Maxima, sir.
Maxima, correct. 4 by 3. What is 4 by 3? Yes, Ravi Shankar, do you want to say something? Ravi Shankar? Okay, we just wrap up this session. Okay, I will send this PDF. Okay, and next time we will start with some unequal intervals and we will do some numerical integration also. Okay, okay. Is it clear? Is are the things clear? Whatever taught, are these things clear? Are the things clear? Yes, Divya, Gomati, Priyadarshani, Ravi Shankar, are these things clear?
Yes, sir. Clear, sir.
Yes, sir.
'Yes, sir.
Okay. Do you have any doubt?
'Yes, sir. 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 'Yes, sir.
Okay. Bessel, we took Bessel interpolation, then we took Newton's forward and backward with first and second derivative, right? And we just saw the maxima minima conditions, right? Okay. If you find any difficulty, you just ask me the doubt. Okay. In the next session. Okay. Okay. Thank you. Have a nice day.